All right, so here we have a double integral whose integral is impossible to compute as is, right? I was going around seeing your work, and I've still seen people trying to do this integral, and I've seen many different answers, like some people writing down like y cubed over, some people wrote 1/2 e to the y squared. Some of you wrote whatever. I mean, you try it, whatever you write, it's not going to work. Okay. The integral of this cannot be represented by any of the sine, cosine, exponential, anything that you know. Okay, and therefore you should know right off the bat that the change of integral is necessary. By the way, there are many other functions where the integral doesn't exist. Maybe, I hope you've seen these in calculus 2, but like things like this. That's an integral where the antiderivative doesn't exist. Did you learn something like that? Did you learn that this integral doesn't exist, right? So this is another example of where the integral does not exist. And what you can do is, what scientists did was they just wrote it as sine integral function. So, because the integral of this function apparently is important in optics and stuff like that. So they really need the antiderivative of this function, whereas the antiderivative cannot be represented by any of the functions that you know. So what choice do they have? Rather than writing this integral with everything so complicated, they just said, okay, we're just going to define a new function, which is the antiderivative of this. And there are zillions of functions where the antiderivative cannot be represented by the basic functions that we know. Okay, and this is one example. So we really need to know how to change the order of integration to do the integral. And the first approach is to draw the graph, the domain, draw the domain. And remember, if you have dy here, that means this is really y equals to and y equals to. And therefore, you need to draw the graph of y equals to 1/2 x and y equals to 8. That's the first step in drawing the domain. Okay, y equal to 8, that's a horizontal line. And then y equals to 1/2 x, well, that's a line passing the origin with slope 1/2. And because you're starting at this line and you're ending there, going up, it looks like it's somewhere here. And then looking at the x values, the left bound for the x is 0, the right bound is for 4, which happens to be exactly the point of intersection of the two lines. So if you were to paint this region between 0 to 4, starting at this line and ending at that line, you're going to get this domain. Okay, so that's the domain of integration. Okay? That's the first step in changing the order of integration. Okay? You have to draw the domain. Now once you draw the domain, the next step is, well, I want to go from dy dx to dx dy, meaning that whatever you write here should now be thought as x equal to something, x equal to something. And also, because dx is inside, you're trying to paint rightwards, so you're trying to go this way. So you have to start here, and you end there. Okay. All right, so what is the equation of this line? X equal to 0. Right? What's the equation of this line? Well, I have it right here. That's the equation of this line, right? But this is not good because it's not in the form of x equal to. So what do? We solve for x, right? So we solve for x, multiply by 2. So 2y is equal to x. So we put 2y here. And then now you have to figure out what to do with the y. It's from point to point, value to value. It's from curve to curve, point to point. So what's the y value? What's the minimum y value? 0. What's the maximum y value? It goes way up to 8, right? So that's it. Oh man, I messed up, I think. Y.
think it's just a 0.
Sorry.
No.
This should have been changed. 8. There was a problem with the question. Sorry about that. They meet at 8,4, not 4,8. I really wanted the points to be so. Yeah, so y goes from 0 to 4. All right. So that's going to change the answer for okay, so I messed up the bounds. Sorry. Okay, so now this integral is much easier because if you're integrating a function of y by x, what happens? This is considered as a constant, right? Integrating a constant, it's like integrating 1 because this can be pulled out. So if you integrate 1 by x, you get x, giving you e to the y squared times x. You still have to plug in the endpoints, which is 0 and 2y. dy is still left. You still have to plug in 0 and 4. Okay? Now what? You have
To plug in 2y next.
to plug in 2y into x, so it's
2y.
2y e to the y squared dy 0 to 4. And this one can be done by integral, by u substitution, right? Set u as y squared, du is 2y dy. So dy is equal to 1 over 2y du. So everything's good now. And by the way, some people don't change these values at all, but I suggest that you do. Okay, so when y is 0, this means y is 0. What's the value of u? U is 0. Okay. When y is 4, what's the value of u? 16. 2y, we tried to change from y squared to u. dy is 1 over 2y du. So 2y cancels. And integrating e to u by du is easy. It's e to u. And if you plug in 16 and 0, it's e to 16 minus e to 0, which is e to 16 minus 1. So that's the final answer. Okay. Now, let me elaborate a little bit about this thing, because I realize that some of you haven't learned to change the bounds. If you are not changing the bounds, then you would be writing down y equals to 4 and y equals to 0, and it will be carried over here, y equals to 4 and y equals to 0. The problem with this is that you cannot plug in 4 into u, because this is u and that's y, right? So you would need this one extra step, which is to write e to u as e to the y squared, and then you plug in 4 and 0, and then it becomes the same answer. Okay? So if this is the way you were taught, which is not the correct way, but I mean sometimes when the professors don't have enough time, they just do it this way. They don't have to explain anything extra. So, but try to do it the other way, where you do change the bounds. It makes things simpler. Right? All right. So that's the subject of changing the order of bounds. I just have one more